Okay, here we go. It's the second half of this video. This question is telling us, I'm going to zoom in here a little bit on this for us. There we go. So this question is saying, drag and drop each graph into the box that correctly describes the relationship. Okay, well, we can see that these are positive correlations because they're going up. These are negative correlations, so they're going down. Okay, so there's only one with positive, so obviously I'm going to drag that one over there, right? And then remember correlation, if it's close to the line, that's a strong correlation. So that one's going to go there, and therefore that one's going to go there. All right, you should have had that one right. Oh, remember our whole unit about the box plots? I've never seen box plots before until they didn't have this when I was your age. So it's kind of cool. The first thing I would do is I would go through this and go put some numbers on, right? Like you can clearly see that like 18 would be here, but then right beside it, 17, like this would be 17, this would be 18 in your mind. And again, you can draw lines on your own screen like I showed you in the video, 10, etc. Okay, so it says select two correct statements. All right, well, let's have a look. The student who read the most books is in class A. Well, that's a lie because look, the max, right? The high on your range, the max is in class B. So, nope, not that one. The range between quartile 1, so remember, quartile 1, and which is going to be right here. Quartile 1. And quartile 3 is 8. Okay, let's check. We have 8. We have 16. Okay, so that is true. That is true. I like that one. Okay, so far so good. The median, remember middle point right here, median of class B is, of class A, pardon me, is higher than the median. Well, yeah, because look, this number is higher than this number. Yep, and I would still always check the last one. The range of the number of books read is larger. So they're saying this range is large. Well, obviously not. This has a much bigger range here. All right, so B and C. Next question. An ice cream company wants to determine the number of ice cream treats that will be sold each day. There's your kicker. Ooh, I'm asking. Oh boy, be careful. See, there's keywords like this you got to focus in on. Wants to be able to predict the number of ice cream treats to be sold each day. Which piece of information would be least? Okay, so what do I not need here? Least helpful to make this prediction. Okay, so might I want the day of the week? I might. They're asking me for each day, so I'm probably going to want that one. The average daily temperature, probably, because let's face it, we're going to sell more ice cream when it's smoking hot out. The past daily sales of ice cream treats, I'm probably going to want that because then I can look like, what did I do last year at this time? The cost of packaging the ice cream. Well, they're not asking me. They're asking me for the sales, right? Like an ice cream company wants to be able to predict the number of ice cream treats that will be sold each day. This is asking me about the costs. So no, I don't need that. All right. A radar counts the number of vehicles passing through an intersection. Every day, Monday to Friday, the data is recorded. A model of relationship exists here. Okay, so we've got a scatter chart here. So now we look and go, all right, based on the model, which prediction is correct? Okay, so something's true and something's false. Let's have a look. The number of vehicles passing through the intersection will remain constant. Does that look constant to you? Constant would be everything straight across. No. The intersection will have twice as many vehicles passing through it at 1 than at 9. Okay, so 1 o'clock. Twice as many to 9 o'clock? No, those almost look the same. No. The number of vehicles passing through the intersection is always increasing. Is this always increasing? No. Gosh, I hope it's the last one. The busiest time of the day between 5 and 6. Between 5 and 6, you bet. That is the busiest time of the day. Next page. Geometry. Now, don't forget, I did show you that formula. You get all the formulas, okay? So you don't have to know the formulas. It'll actually tell you about Pythagorean theorem anyways. But, I mean, let's face it. At this point, I think everybody knows Pythagorean theorem, right? You're always looking for the right triangle, and always across from the right triangle is always what we call the hypotenuse. Always, always, always. It doesn't matter if this is A and this is B. It doesn't really matter what the letters are. I always say like A, B, C, just to make my life easy. C squared equals A squared plus B squared that's just something you have to know in life, okay? It's pretty easy. So here we go. A wire connects to the top of a hydropole to the ground 4 meters away. The base of the hydropole is 13 meters high. All right. Oh, look, they even gave it to us. It's so nice. Which measurement is closest to the length of the wire from the top of the hydropole to the ground? So we are looking for this C, right? And we know C squared is A squared. So it's literally just 4 squared plus 13 squared. 14 squared is 16. 13 squared is 169. I would get my handy little calculator out. I would say 16 plus 139. Oh, sorry, 169. Let me try that again. Clear. 16 plus 169. Okay, 185. So 185 is C squared. So C is equal to the square root of 185. And on my trusty little calculator, I have to press this button here. And then I say 185 squared is 13.6. And I'm hoping we have a 13.6 answer. Let's have a look-see. Voila. There we go. Okay. I hope I was on the screen when I did that. Okay, what is the value of x in this diagram? Okay, now you should know this, right? We talked a lot about ulterior angles and inside angles and rules of triangles. We know that from here to here is always 180, right? So 180 minus 128, again, don't be a hero. Get your calculator out if you're not 100% sure. So 52. So we know this one has to be 52. All right, so the same thing here. One here is going to be 180 minus 103. 180 minus 103, 77. Well, if this one's 52 and this one's 77, 180 minus 52 minus 77, 180 minus 52 minus 77 is 51. And I have an answer of 51, right? So you have to be able to do that on the fly like this. You should be able to. We did a lot of examples on triangles. So you should be able to do this. Now, for something like this, I would never expect you to have any formulas memorized. Remember, they give you the formula sheet, okay? These two cylinders and this cone all have the same circular base, okay? So again, focus on what you know. We have the same base and the same height. So they're not telling you what they are. They're just telling you it's the same. It doesn't matter what they are. The first cylinder is completely filled with water. Then the cone and the second cylinder are empty. The water from the first gets dumped into here until it's straight up full. The rest of the water then gets dumped into here. How much full will this one be? How full will this guy be? Okay, well, you know what? The only way you're going to be able to do this, I mean, if you're really good at visualizing things, you might be able to do it in your brain, but I had to look up the formulas, right? So we have to find out that the volume of the cylinder, volume equals pi r squared h. And then the volume of the cone, volume equals 1/3 pi r squared h. So now you have to almost look and go, oh, Whatever's in here, a third of it is going to be able to get filled up in here. So I take a third out of here, I'm going to have 2/3 obviously left in here. Okay, that's your answer. That one was a little bit tricky. It was a little tricky, but you know, it's all doable. It's all doable. Oh, my favorite unit, financial literacy. Oh, I just love it. I love everything about business. Demonstrate and the knowledge and skills to inform decisions. Okay. Oh, loans. I just finished marking some of your loans and you guys all did a great job. Key with loans. Simple is cheaper, right? So if you want to take a loan out, you want simple interest because it's going to result in less interest. But if you're going to invest your money, you want compounded interest because money makes money. Interest makes interest, right? Dustin wants to get a loan. Okay, loan. Complete the statements. Dustin should go with the bank that offers the monthly interest rate of. Okay, so what do we want if we want a loan? What did I just tell you? We want the lowest because it's going to be the least amount of interest, right? The least amount of interest. Always get the lowest interest that you can get, all right? Then it's asking you, well, you should pay back the loan over what? Like how much should you pay? You might go, well, if I paid over 5 years, I'm going to have lower payments. Yeah, but you're going to have more interest. And this is all about, we want to get the least total amount of interest. So you want to pay that off as fast as you can. You want 6 months. You want to pay it off fast as you can. So it's less interest. Higher payments to start with, but less interest overall. Get this right in your brain. I don't know if they're going to ask you a loan question or if they're going to ask you an interest, like you're putting money in the bank. Then what you want? Then you want the highest interest and you want it compounded as frequently. Like if they'll do it every month, do it every month. Most of them will do it like every year, every quarter, but you want it to be compounding as many times as you can. All right? Almost done. I think this is our last question. Here we go. So a person purchases 2 different items. The graph represents the value. What are we looking at here? We got item A and item B. Let's talk about it. Item something is an example of appreciation. Well, this is straightforward. It's going up. Item A. Item A is appreciation, up to the sky. Like items that appreciate, often jewelry. Jewelry, like my beautiful ring here, right? It goes up in value, right? Antiques, homes, or property, right? So those, they go up in value. Items that depreciate. Number one thing that depreciates is cars, right? So again, unless it's an antique special car, okay? My friend has like a 69 Mustang, Corvette, right? That thing goes up because he's a collector, all right? So, but in general, cars go down. And that's why, you know, when I have you listen to Dave Ramsey, and he's always like, I just think is so smart with everything financial. They lose about 60% of their value in the first 5 years, right? It's your biggest depreciable asset. Like, don't buy a car that you can't afford. It should be, you know, no more than half of your salary. So let's say you make $50,000 a year. You should never buy a car for more than $25,000, right? And even cheaper, like pay cash for it, save up, pay cash. These are all things you need to know in your life. From the date of purchase, the value of the item appreciates by 20% after how many years? Okay, so now we're on item A, and it wants to know how many years does it take to reach basically a 20% increase in value. So now you have to think to yourself, well, look, it cost me 500, right? It cost me 500 and I'm going up 20%. So I need to know what is 20% of 500, right? And again, if you don't know, it's okay. Go 500 times 0.2. That's 20%. It's $100, right? So it's going up by $100 when? So, okay, let's look. So it goes to 500. 6, 7, 8, 9, 10. So 600. So when is it going to reach this 600? When is it going to reach this 600 point? Right here. At 2 years. right? So you have to be able to read these charts as well and understand what it's saying. This asset, let's pretend it's a piece of gold necklace or something. $500 is what I paid for it. It's an appreciating asset. It's an appreciating item. And when did it increase by at least 20%? Well, 20% of 500 is $100. So when did it reach 600? I go, look, and there's my 600, and I go over to my graph, and that's how I find it. All right. If you have any questions on any of the EQA practice work that we have done, please, please, please reach out. I am here to help, and we will get through this together. You got this. You guys are so smart. Such an amazing class.